Hello everyone, myself is Lalit Sharma. Now in my today's video lecture, I will start with the new topic in definite integration, that is properties of definite integral. This is very important. So the topic title is properties of definite integrals. Okay, properties of definite integrals. Now, in this case, the first few properties are, very easy to see, but there will be no question based on those properties. The first property says that if lower limit and upper limit coincides for any definite integral, then answer is 0. Obviously, because the final answer will be f of upper limit minus f of lower limit. If both limits are same, so the f values are same, so when you take them in subtraction, so the value is 0. It's very evident that if upper limit and lower limit coincides, then the value of integral is 0. Second property is also very evident, which says that integral a to b fx dx is equal to minus integral b to a fx dx. That is, which says that if you change the if you swap the upper limit and lower limit, then the final answer comes out with the negative sign. Obviously, because this answer is f of b minus f of a, so this becomes minus of f of a minus f of b, and this is nothing but f of b minus f of a only. So this is very evident. So these two properties are not required any application based question, but in between some at some steps or in some of the questions we can use them directly. Okay, so now I'll start with the first property, that is the third one, which is the important one. This property is very important. This is split up property. Okay, this is known as split up properties. Now, as the property says that it is the split up property, so in this case we'll split the given definite integral. So suppose we are given any definite integration a to b fx dx. So we can always write this integration as a to c fx dx plus c to b fx dx. Okay, that is, we can always break at c provided that this c is in between a and b. ओके अगर a और b के बीच में ये पॉइंट c आ रहा है, so you can always break your definite integral like this, that a to b fx dx is equal to a to c fx dx plus c to b fx dx. and you will say, sir, क्या हम इसको दो में ही break करेंगे या we can break it in more than two also? Yes, we can. So in general, if there are points say c1, c2, c3 up to cn, so we can always break this integral as a to c1 plus c1 to c2 plus c2 to c3 and so on, plus cn minus 1 to cn, and the last will be cn to b. So in any finite number we can just split this integral, and this is very important property. I'll give you some examples to illustrate the concept that how this property is important. Okay, so let us start with the application based question on this split up property. So let us take the first example on this split up property. Now this first example says that evaluate integral 0 to 2 mod x minus 1 dx. Very easy. Okay, now we know that the function mod x minus a changes its behavior at the point x equal to a. That means x equal to a के right पे कुछ और behavior होता है इस function का, left पे कुछ और होता है modulus function. Why? Because I hope that you recall that this mod x minus a is actually x minus a only if x is bigger than a. This is 0 if x equal to a, and this will be a minus x if x is less than a. This is the definition of this modulus function. So a is the turning point, and clearly what is the turning point for mod x minus a? It is a, जहाँ पर mod के अंदर वाली quantity 0 होती है, that is the turning point. So in this case 1 is the turning point and it is lying between 0 and 2. So firstly we observe this. Okay, we observe this. We observe that 0 less than 1 less than 2. So therefore, can I split this integral 0 to 2 mod x minus 1 dx as 0 to 1 mod x minus 1 dx plus 1 to 2 mod x minus 1 dx. I hope this is clear. This is something which I can do. Now, 0 to 1 means the values are bigger than 0 but less than 1. So when x is less than 1, so this mod x minus 1 comes out with negative sign, that is 1 minus x. So this integral becomes 0 to 1, 1 minus x dx. Okay. But when I take 1 to 2, that means 1 se bada, 2 se chota. If x is bigger than 1, then clearly mod of x minus 1 is x minus 1 only. So this is nothing but 1 to 2 x minus 1 dx. Now you just simply evaluate the definite integral. Property is there, split up property laga di hai. Now this question becomes normal questions of definite integral, evaluation of definite integral. So this integral will be x minus x square by 2, 0 to 1. This integral will be x square by 2 minus x, 1 to 2. So firstly I'll put 1 and then 0. When I put 1, it will be 1 minus 1 square by 2, 0 पे 0 ही हो जाएगा, and plus 2 में this will be equal to 2 square upon 2, that is 4 by 2, 2 minus 2 minus 1 by 2 minus 1. So this is what you are having. So 1 minus 1 by 2 is half, plus this 2 minus 2 is 0, half minus 1 is minus half, minus minus plus. So half plus half, so final answer looks like 1. Just see the calculation part. After through with the split up property, I have simply used the evaluation of definite integral wala part, which I have already covered in the first 3 video lectures. So I hope something is clear to you regarding this split up property. Now let us see one more. Suppose the questions given, example 2, this is my example 2, that evaluate minus 1 to 1 e to the power mod x dx. Okay, now this question comes again. Whenever mod functions with the modulus function comes, any question, any integral with modulus function comes, then obviously search for the turning point and see whether the turning point is lying within the given limits or not. If it is so, then always go with the split up property. So in this case, in mod x, we know that x equal to 0 is the turning point, and 0 is clearly lying between minus 1 and 1. I hope this is clear. So can I write this integral as minus 1 to 0, okay, e to the power mod x dx, plus 0 to 1 e to the power mod x dx. I hope this is clear. Now also I know that if x is less than 0, then mod x is minus x. And if x is bigger than 0, then mod x is x. We know this property of modulus function. So can I write this integral further as minus 1 to 0 e to the power minus x. Why? Because in x less than 0, mod x takes value minus x, and in 0 to 1, obviously this is e to the power x dx. Now when I evaluate this, the integral looks like minus e to the power minus x, minus 1 to 0, plus e to the power x, 0 to 1. So this will be minus 0 पे तो 0 ही वैल्यू होगी, और minus e की power minus 1, when you replace in place of x, this becomes e की power 1. I hope this step is clear. And then plus e to the power 1 minus e to the power 0. So this will be minus e to the power 0 is 1 minus e, and then plus e minus 1. So this will be minus 1 plus e minus 1. So it will be 2 times e minus 1. I hope this is clear to everyone. So this completes this question, that the answer is coming out to be 2 times e minus 1. So I'm giving you this split up property in various cases, in exponential case, in modulus case. Now I'll give you in the greatest integer case. Now suppose he says that evaluate the integral. This is our example number 3. He says that evaluate the integral 0 to 3 greatest integer x dx. Now this square bracket x stands for the greatest integer function, greatest integer x dx. Now in this question, we can just split this integral like this, that it will be 0 to 1 greatest integer x dx, plus 1 to 2 greatest integer x dx, and then plus 2 to 3. Okay, now when x is bigger than equal to 0 but less than 1, so the value of this will be 0. I hope you remember the definition of greatest integer. It is the immediate integer on the left. Okay, similarly in this case, the value becomes 1 in 1 to 2, and in 2 to 3 the value becomes 2. I hope this is clear. Now this integral vanishes because 0 into anything will be 0 only. So we'll start with this integration will be x 1 to 2 plus 2x 2 to 3. So this will be 2 minus 1 plus 2 times 3 minus 2. So this will be 1 plus 2, that is equal to 3. So the final answer for this is coming out to be 3. I hope this is clear. Now in this context there can be long questions also. These are the short questions, smaller one. Now in this context we may have long questions also. What type of long questions? That he says that the evaluate, this is our example number 4, that evaluate say 0 to 4 mod of x minus 2 plus mod of x minus 3. Suppose someone says that evaluate this. So I'll just apply the splitter property, and once the question comes in the form of direct evaluation of definite, I'll just leave it. So here I observe that 2 and 3 are the turning points, and both are lying between the range 0 to 4. So I can I can break this integral as a 0 to 2, then next is 2 to 3, and then next is 3 to 4. I hope this is clear because I have to cover from 0 to 4. So 2 or 3 पर मैंने से break किया है. Now when 0 to 2 means x is less than 2. When x is less than 2, by default it is less than 3 also. So this comes out to be 2 minus x plus 3 minus x. Okay, I hope this step is clear. dx. 2 to 3 means x 2 से बड़ा है, 3 से छोटा है. So this will be x minus 2, but this will be 3 minus x. I hope this step is clear. Okay, and from 3 to 4 means x is bigger than 3. So when x is bigger than 3, by default it is bigger than 2 also. So this comes out to be x minus 2 plus x minus 3 only. So this is how you integrate. Now this question becomes a normal question of integration. The main part, the splitter property, I have given that how to evaluate the splitter part. Now the rest is simple calculation. What this function becomes? This becomes 0 to 2, 5 minus 2x, which can be directly evaluated. This becomes 2 to 3, only 1 dx, which can be directly evaluated. And this becomes 3 to 4, 2x minus 5 dx. So I hope this I1, this I2 and I3 all can be calculated, and then you just replace back the values in this I1 plus I2 plus I3. This gives you the final answer. This is a 4 marker. Okay, it is slightly the longer one. Why it is the longer one? Because in this case you have to evaluate 3 different integrals, I1, I2, I3. So that's why it's a long question category. Now again in this long question category you may have question of this type also, that evaluate integral 0 to 3 pi 2 mod x cos pi x dx. Now see carefully, this is a very important question from your board point of view. This is a very important question. 0 to 3 by 2 say mod x cos pi x dx. Now we have to discuss the cases. So if we take firstly x between 0 to half, then what I observe, when I take x between 0 to half, then clearly my pi x is between 0 to pi by 2. Okay, so in this range 0 to half, my x is positive and my cos pi x is also positive because the angle pi x is lying in the first quadrant. So mod से as it is बाहर आ जाएगा x cos pi x dx. I hope this step is clear. Now when I take from half to 1, half to 1 means when x is between half to 1. So clearly the pi x becomes between pi by 2 and pi, that is cos is negative. So when you multiply a positive quantity with the negative 1, the final answer is negative 1. So this will be equals to minus x cos pi x dx. And obviously from 1 to 3 by 2 also the same process will be there, that the pi x is between pi to 3 pi by 2, and we know that between pi to 3 pi by 2 also the cos is negative in the third quadrant, so this comes with the negative sign only. So instead of breaking from half to 1, I can directly take it from half to 3 by 2, because in both the cases it comes out to be minus x cos pi x. Now this is your I1, this is your I2. So you simply evaluate x cos pi x by parts, and then if you replace down the value, you will be able to do it. So how to do with x cos pi x integration? X is the first function, cos pi x is second. So first function as it is, integration will be sin pi x upon pi minus 1, then sin pi x upon pi. Okay, I hope this step is clear. And then this will be x sin pi x upon pi plus 1 by pi square cos pi x. So this will be the integration of this quantity. First, when you calculate I1, take limits from 0 to half. Then when you calculate I2, take limits from half to 3 by 2. Use the fact that cos vanishes at the odd multiples of pi by 2, and accordingly sin pi by 2 is 1, sin 3 pi by 2 is minus 1. You will be able to find the answer for this question. I hope the main part I have done, that how to break it between 0 to half, and then I have break it from half to 1, and then 1 to 3 by 2. Although in half to 1 and 1 to 3 by 2 it have the same behavior, that is from mod it comes out with negative sign. So I have collected both of them, and therefore I have taken from half to 3 by 2 as x minus x cos pi x, but between 0 to half it will be plus. So we have to split from 0 to half and then half to 3 by 2. This comes with the knowledge of trigonometry also. The knowledge of quadrant system is also required. Only then you'll be able to do it this question. Okay. Now let us see one more example in this category. Suppose he says that evaluate a 0 to pi by 2 mod of sin x minus cos x dx. Suppose this question comes. Okay, so I have just told you that in 0 to pi by 4, I have told you in the previous questions also that in 0 to pi by 4 my sin x is less than cos x. So sin x minus cos x is negative in this range. Okay, and in pi by 4 to pi by 2 my sin x is bigger than cos x, that is sin x minus cos x is positive in this range. So therefore I'll just split it from 0 to pi by 4 and then plus pi by 4 to pi by 2. Now in 0 to pi by 4 my sin x minus cos x is negative, so it comes out with negative sign from mod, so it turns out to be cos x minus sin x. And from this it is positive, so it comes as it is sin x minus cos x dx. So when you integrate this, this will be sin x plus cos x. So sin x plus cos x 0 to pi by 4. Okay, and this will be minus sin x minus cos x minus sin x. So minus of sin x plus cos x pi by 4 to pi by 2. Now you can evaluate. Firstly, you put pi by 4, so it will be sin pi by 4 plus cos pi by 4. So this becomes root 2 only, and minus sin 0 plus cos 0, that will be 1 only. So root 2 minus 1 will be the value of this, and then minus, when you put pi by 2 here, it will be 1. Okay, then when you put pi by 2 here, it will be 1, and when you put pi by 4 here, it will be again 1 by root 2 plus 1 by root 2, which is 2 by root 2, which is root 2 only. So when you just open this bracket, it will be root 2 minus 1 plus root 2. So it will be 2 root 2 minus 2. So if you take 2 common, root 2 minus 1. So 2 times root 2 minus 1 will be the solution for this. So I hope I have been able to, justify, or I have been able to illustrate the concept of split up property in definite integral. I have told you that how to split at one point, maybe in more than one definite integral. So it depends upon the structure of the question, but whenever modulus function comes, or something of that kind comes, where I can break the function at a point from which its behavior gets changed, so I'll apply the splitter property. I have given you examples related to 1 marker, 2 marker, even 4 marker. So if you complete these questions, then you'll be in a good position, and I'll advise you to attempt questions from your exemplar textbooks or from your NCERT textbooks to give you more concept clarity. Thank you.